Welcome to Full Momentum and HEC-RAS podcast. This is episode number 39. I'm your host, Ben Carey. Here joining me, as always, Chris Goodell, as well as a special guest today, Paul Drew. Paul, welcome to Full Momentum.
Yeah. Hi, guys. Welcome. Thank you for having me. Appreciate this.
Absolutely. We're really excited to introduce the HEC-RAS Full Momentum world to Paul. Paul's one of our newest H&H and dam safety lead engineers here at Kleinschmidt, and a good guy to talk to about all things engineering related around hydro. But I know I've enjoyed kind of working on some RAS related projects too. So I thought we'd have Paul on to get into a special topic today, which is going to be dam breach analysis using HEC-RAS. We're going to kind of keep it informal and fun. So really looking forward to that topic. But before we get into introducing Paul and discussing dam breach analysis, Chris, I do want to give you a chance to think back and remember the fond memories that were this year's Beavers baseball season, because it was a good one. Like you said, it was a successful year, but unfortunately, I know came up a little short.
Yeah, I mean, so if you've listened to our podcast before, Ben and I like to talk a little bit about sports. Ben is a Gonzaga super uber fan, and I don't know if I'm quite at the same level with my Oregon State Beavers, but I'm pretty up there and love baseball season because we usually put out a good product. My goal for this year, Ben and Paul, was for my team, the Oregon State Beavers, to go to the College World Series and not be a 2-and-barbecue team. So in other words, at least win one game. And we did that, so I'm happy. Every time you win a game, you get closer and closer to winning the whole thing. You think, oh, we're getting there. We could do this. We could do it. And then you don't, and it's disappointing. But when you look at the grand scheme of things, the whole season, this was a fun season. It was a lot of fun. We did really well. Made it to Omaha, College World Series. Couldn't ask for more. And I think we're going to have a solid showing next year. So pretty happy with that. I know, Paul, you were following the college baseball real close, huh?
Not directly, but funny story for you, Ben. I had a call with your brother, and I caught him. He was watching the game behind me. He thought his screen blurred it out. And you could see that he was watching it. So make sure you pass that along to him.
Good. Well, I'm glad you aired him out here on YouTube. That's good.
Well, that's the thing about that tournament is they tend to play a lot of the games in the middle of weekdays, and so it's like you got one eye on the game and the other eye on work sometimes.
Yeah. Well, as an avid follower of the NCAA basketball tournament, I can't cast any stones when it comes to watching work tournaments right. during work. But yeah, anyway, that's good stuff. I know, obviously, Chris, you mentioned, I'm kind of a diehard Gonzaga fan. Chris, you're a diehard Beavers fan. Paul, is there a particular sports team that, affects your mood when their season comes to an end?
I mean, I could lie to you and say no, but I would say, for a long time it was professional baseball, but I never came back from COVID. I lost interest in pro baseball and haven't come back. I've probably been following the Bucks a lot more since I moved back to Milwaukee 11, 12 years ago. And it helped when they had a guy named Giannis they drafted and got his whole journey. So definitely, very much a Bucks fan. Football season round, still watch the Packers and local Wisconsin sports, but those are probably the two teams I follow the most. And then always watch whatever major tournament is for golf and just follow that. So I tend to not watch nearly as much college sports as you boys, but I'll still watch it if it's on.
So are you a Brewers fan then, or were before
COVID? I was.
Yeah,
That's a tough team to follow your whole life. So I watch them here and there, but just have lost the itch to watch baseball, unfortunately.
Yeah, well, as a Mariners fan, I can sympathize with the struggles of being a Brewers fan, because the Brewers have had quite a bit more success than the Mariners the last 25 years. So.
And if you're classifying that, that's a tough spot to be in, right? For sure. Yeah, I feel your pain.
Good. Well, that was a good opening here. Appreciate Chris again following the Beavers during the podcast. Even though we probably only got a couple episodes of discussion on them, it's always fun to recap where we're at with that. But let's transition to introducing Paul. Again, I mentioned at the beginning of the show, but Paul came on, I think, almost exactly a year ago to Kleinschmidt and is our section manager of our dam safety team. Has a lot of hydraulic engineering background in his experience too. So, Paul, I'll just kind of turn it over to you to introduce yourself. If you could just let folks know, including Chris and I, just a little bit about yourself, where you grew up, where you went to college, how you got to the point that you were, doing hydraulic dam safety engineering, and what you do now.
Yeah, no, happy to. Hopefully the accent doesn't come through too much, but I'm a Wisconsin Midwest boy. Lived in and around Milwaukee for a good chunk of my life, but also had 2 tours of duty outside of Chicago. So I've lived there. I've also spent time in Madison area as well. But we moved just outside of Milwaukee about 11 years ago, and we've been there since, or been here since. My oldest daughter starting sophomore year of high school coming up here, not college yet, and then my youngest will be starting 6th grade. So we've got roots here now. My start in engineering actually a little bit interesting there. I am a Milwaukee Panther, so I went to school here in Milwaukee, but I got an internship at just coming out of high school. So I was 18. I had the lowest possible level of responsibility. I was breaking concrete cylinders in the testing lab. So that was my start in civil engineering. Once I got good at that, I started doing proctor tests. I got out doing on a field survey crew, observed some construction, was behind a drill rig, and eventually got enough credibility where they let me start doing CAD drafting, and eventually got a shot. I think I was in maybe my sophomore or junior year of college, and they had a big need to pump out a lot of HEC-RAS models, and I had no idea what HEC-RAS was. So I went down to our Chicago office for a few weeks at a time and just worked with a lot of really good folks. I think it was version 3.1 at that time. Chris, it feels about maybe 2005-ish was probably when that was, 2006 maybe.
You might have been close to right around the 4.0, but anyway, yeah, the 3 somethings. Yeah.
It was in the 3s, whatever that number was. And actually, learned doing that, a lot of like bridge replacement modeling. We did some spillway hydraulics. Also, we had a big program doing a lot of floodplain analyses too. So I got to, get my chops on those. But one thing that's interesting is, one group who I'd say was the newer, younger engineers were all using RAS, but one of the holdouts, one of the older guys in the team, didn't trust it. He was a HEC-1 and HEC-2 guy. So if you worked on his projects, you had to learn HEC-1 and HEC-2, and then, FEQ and HSPF and all of those models. So I was pretty fortunate. By the time I got out of college, I had used all of those different types of modeling software. I had been in the field. I had done some construction work and some CAD drafting and design. So it's almost like I got a master's degree in civil engineering, while I was doing my bachelor's. So that was where I started. And I'd say, kind of continued there for a year or two, and then really transitioned into dams and hydropower, and have been doing that primarily ever since. So that's my short journey, but also have picked up, I've done one and 2D RAS, but also some CFD modeling and led those projects. When Flow 2D was really trying to make a push in the market, we picked up and played around with that a little bit before HEC-RAS went to 2D. So touched a lot of different types of modeling software along the way, and now I get to do a whole lot less of it myself. It's more of scoping it, directing it, and reviewing it. You guys have built a pretty awesome team here at Kleinschmidt for the pipeline of folks that are pumping out these models. So that's been a really good fit, that I can kind of operate at the right level, and folks can help execute that work.
Paul, I got a question for you. You've obviously have learned a lot of software models, applications over the years. um, modeling software, and some of them are very different than others. And I'm wondering, how did you learn? What was your strategy when somebody said, "Hey, you got to learn HEC-RAS, or you got to learn HSPF or Flow 2D or whatever it was"? What was your strategy to go from knowing nothing about it to being able to use it on a project?
I was obviously reading your blog, right? And your
I was
book.
not fishing for that, Paul,
Yeah.
at all.
That
Okay,
looked pretty fishy, Chris.
No,
Before I
I
get there, I
can't.
just a question I have though. You had a book called The RAS Solution, right? And I can picture it on my coworker's desk. Did it have like a bent over canoe against a tree?
So
Am I thinking of
that
the right
was
thing?
that was the book on HEC-RAS automation called Breaking the HEC-RAS
Yeah,
Code.
that's
And
right.
yes,
Yep.
it has a canoe wrapped around a tree about like 10 feet up the tree. And
Yep.
I thought, hey, this looks like a really nice calibration mark I can use for my
Yeah.
model that I was about to build. But anyway, no, I was really not, honestly, not fishing for that, because this question comes up a lot. Like how do I learn this software, whether it's RAS or something else? And I always like to know people's strategies so I could kind of pass that on when the question comes up.
Yeah, yeah. I wanted to at least weave that in there. No, I would say what really helped, for me just on the process early is, I'd have a more senior or at least seasoned engineer that would kind of walk me through, hey, this is what the software is doing. This is what we're trying to get out of it. And really, my process for learning was just using and getting started and trying things out. I probably read the manual and the technical reference guide, if those things still exist, front to cover a number of times. And a lot of the times it was just, I could get instruction, but the way that my process and learning is just by doing it and figuring out. And I'd say for HEC-RAS specifically, it was when I started doing unsteady modeling and your model blows up for 500 different reasons you have no idea. The more time you spend working on it and you kind of figure out what makes it tick, that was probably the game changer for me. So, without having a real good process to describe, it's really just get started, try it, ask good questions when you're struggling. I always tell folks, here's something to get you going. Here's kind of the process is what we're trying to do. Get started. And if you feel like you're spinning your wheels, all right, let's talk, but at least give it a shot and try to figure out what you're doing wrong. And a little bit of probably a little bit more back and forth early as you're getting started, but then giving them, a longer line, after that. But other models, I'd say the same thing. Like CFD was probably a tough example because that's like a full, maybe week course just to be introduced to it. And then the same thing, there's just so much complexity built in that, it's a lot of doing, there's customer support, there's talking with your coworkers. So I'd say I tend to learn best when I'm attached to somebody and can learn the process, but also just struggle through it a little bit because you're going to learn it a little bit trial by error sometimes.
Yeah, I don't envy newer H&H engineers that are coming in and the first models that they're learning how to use is, 2D RAS,
Yeah.
Flow 2D, CFD, Flow 3D, Star CCM, right? These like more complex 2D and 3D models, partially just because of the complexity that it takes to construct those models, but also just because the runtimes make learning on the fly and like working through and spinning your wheels just really difficult. You think back to running a steady state RAS model and how many times you could run that in an hour and, have your model crash and not work. And you can just like really quickly try stuff and look stuff up and troubleshooting is just, quite a bit easier. I would try to picture myself doing that with a CFD model now where you're trying something, running it, takes 4 hours to run. Now you get some input or output that tells you, something didn't work quite right. It just like kind of expands that learning curve so significantly. I think it's really challenging to come in to the industry right now and be asked to jump right in to that level of model. And that's why one of the things that, Chris and I continue to kind of teach when we're teaching RAS class stuff to folks is kind of the importance and the value of still using 1D modeling where it makes sense. And obviously you always want to use the best tool to solve to solve the problem for the client. But in many cases, like having that basic understanding of how 1D works, being able to use 1D when it makes sense, and then teaching, junior staff how to use 1D as kind of a way to build that foundational hydraulic understanding is it's really critical and I think important. So it's cool to hear, Paul, that, part of the way you developed quickly and effectively was just by learning so many different models kind of within a concentrated amount of time. And that's really neat. As you were kind of explaining that, do you think that learning hydraulic modeling is kind of like learning languages, where if you're kind of learning how to use one, it's easy to add in a couple more because you're kind of learning and thinking about how to use the software in a similar way?
Yeah, I think so. I think you kind of hit on it. You develop whatever process works for you, and then you just apply it to different models, right? I always, to your point about complexity, I always just recommend just start super simple. Like make the model as simple as possible. Let's push some water through it, see what's happening, and then we start building complexity on top of that. The other thing that just always recommend is just having really good notes, Excel spreadsheet, or even a Word document that really just documents all of your assumptions and what worked and what didn't. But to answer your question, yeah, I think once you kind of get a knack for, I'm using a model for something, you can apply it to any number of models. I mean, I remember starting just doing HEC-RAS modeling, but there was a need that someone did slope stability modeling with slope W and seep W. It's like, well, I'm not a geotech, but modeling is modeling, right? You build out your process, you build out the assumptions, understand what makes it tick, and then you can get up and running here pretty quickly. So I think once you get that knack for developing these models or tools for whatever you're trying to do, it usually is, pretty consistent. You'll find if you're in a HEC-1 or a HEC-2 model or a HEC-RAS or HMS model, it's the same thing. You're just inputting the data differently.
So Paul, you were talking about the process, understanding how the model works and how important that is. I agree with that 100%. And I think it's especially more important nowadays when we're getting into models that, instead of like the kind you were talking about, Ben, where it would take, seconds to maybe a minute to run. Now we're talking about run times of hours when we get into really complicated 2D models. So it's that much more important to understand what's happening under the hood, because that's going to help direct you on what you can do to fix the model when it's crashing or whatever. It's, kind of gone are the days of playing whack-a-mole to make your model run. You've got to really be smart about how you approach the troubleshooting exercise, and knowing how it works, knowing the theory behind it, understanding the process that it's going through when you hit the compute button, I think is super important.
Yeah. Good. Well, that was a great opening salvo conversation, Paul. Appreciate the background in terms of how you got into the field here in general, and some background in terms of your modeling experience too. That's really cool. I did not know that you were an old school HEC-1, HEC-2 user, in addition to some of the newer tools.
Paul, you don't look old enough to be a HEC-1.
That's what I was thinking too.
Well, I also say I'm not old enough to have a kid in driver's ed, but here we are. So I'm not sure. Maybe I hide the grays okay, but no, I think it's a combination of, like, if you're in the industry early enough and you have folks that are still clinging to older models, and you just get some different exposure, right? And I'd say, if you have to keep track of all your data to a point where you can do a 1D or a HEC-1 and HEC-2 model, making a HEC-RAS 1D model is pretty simple because you actually have a user interface. You can see what you're building versus like, oh, well, how did I line up my cards or my line of code, and where did it go wrong? I didn't have enough spaces, right? And I don't know if you guys were ever exposed to a model called FEQ, but that was probably my most frustrating model that I ever had to go through. But that was back to my Chicago days, and I don't think anyone's even using that anymore. But that was quite a struggle. So if you have some battle scars with those types of things, we get into HEC-RAS modeling. It's
FEQ
not near.
Was that was a 2D model, right?
No.
Am I thinking of something else?
Based model, yeah.
Okay, I'm thinking of something else then.
Yeah.
Cool.
Yeah, well, I bet that HEC-1 and HEC-2 experience made you a better modeler, though, because you can't help but not understand what's happening behind the curtain, when you're literally in there working on the inputs and reading outputs from a text file. It's kind of unavoidable.
Yeah, I mean every line of code does something different, right? And you need to
Yeah.
understand from the manual not only the line of code but how many spaces. And it's almost like basic accounting at that point, right? To your point earlier, it's learning a different language, and then once you get your process set up for that, yeah, everything else seems a little less painful.
Yeah.
Well, we're gonna take those lessons learned that you just described, and I guess facilitate a conversation specifically around one of the more challenging hydraulic modeling scenarios that any hydraulic modeler will face, and that is doing a dam breach analysis that really tends to stress the software's capabilities when we talk about HEC-RAS specifically, and also those abilities of the modeler. So we're going to talk through that a little bit more here shortly. But before we get into that, I do want to just quickly make an announcement. And that is we have upcoming HEC-RAS training opportunities for everybody listening here. I just want to overview what those are. Chris and I actually just started our summer 2025 1D, 2D HEC-RAS class 2 weeks ago. So we got a good group that's learning how to use 2D RAS currently. And if you missed out on that opportunity, no worries. There are others coming up in the very, very near future. So I'm just going to share my screen here and kind of walk through the different opportunities that are available to folks. We have 2 classes currently planned upcoming. The first is going to be this fall. I believe it starts in October. It's our Fundamentals of HEC-RAS class. This is going to be an awesome opportunity for anybody who's relatively new to RAS, even if you're new to 1D, to kind of get in and learn the basics and foundation of building out successful RAS models. We'll start kind of in more of the 1D environment because, again, that's a great way to learn about kind of how RAS handles hydraulics, what things you need to consider. And then we'll slowly evolve that into very introductory 2D models, so you can kind of get an idea of when, potentially 2D is going to be a better choice than 1D, how you kind of utilize those 2 models in tandem. And that'll be kind of the conclusion of our fundamentals class. So that'll be over the course of 6 weeks. We meet once a week for 4 hours, lecture, and then there's going to be workshops in between. Again, if you're new to RAS, that's going to be a great option for you. And then that class will kind of spill right into our advanced 2D HEC-RAS class. This will be the first time that we've taught this advanced class. And there's a lot of interest out there from former students of ours that took our kind of basic 1D, 2D class. And the idea here was to kind of stretch what we've been teaching. We've kind of slowly incorporated little pieces of rain on mesh or RAS 2025 or terrain modifications, troubleshooting and calibration. These have all been topics that we spend maybe 20, 30 minutes on in our current class. And we wanted to stretch that out and make it a focus for those that are higher end users and really want to, take their modeling skills to the next level. So our advanced 2D class will be offered in the spring of 2026. You can sign up for either of those classes right now, or if you're interested in actually taking both parts of this series, again, they connect directly together and are, I think, a great kind of full way to go from intro RAS user to somebody who can use 2D at a high level. We have the opportunity to sign up for both of those classes at a discount as well. So consider that. Again, the fall class starts on October 1st and runs through November 5th. So if that timeline works for you, definitely go to rastraining.com and consider signing up for that class. The other thing I wanted to touch on is that we officially have launched our referral program through Full Momentum Solutions. This is a program we've been working on for a little bit. It includes some of the gear that you're seeing on screen here with the polos and whatnot. But this is just a way for us to kind of reward folks that have spread the word about taking training through Full Momentum Solutions and the value that they've found in learning how to use RAS 2D. And so it's really simple. All you need to do is take a class. If you've already taken a class, then you already have checked that box and you don't need to take another one. Once you've taken a class from us, if you refer somebody else who subsequently signs up for a class, we'll reach out and we'll give you a free pack of swag. And that'll include a t-shirt, a mouse pad with the various hydraulic reference equations that we use all the time in RAS. It'll include the full shallow water equation breakdown on a mug, a pen, and a trucker hat as well. So all this stuff, basically we'll package it up, we'll send it to you for free. And as a thank you to Paul joining the podcast today, we're going to get him one of these too, so he can get some of this sweet gear. But again, if you're interested in referring folks, we'd really appreciate it. And if you want more information, go ahead and visit the referral program tab of our website. Again, that's at rastraining.com. Chris, anything to add to upcoming training opportunities?
No, it just encourage everybody to come join us. It's a really fun time. In addition to learning all about HEC-RAS, we just have a good time. There's a lot of Q&A. There's a lot of learning back and forth from others in the class too. It's not just me and Ben talking, but it's very interactive. We get people engaged, and bring your questions too. If you got a project that's been stumping you, this is a great place to get some advice on how to fix it.
Yeah,
cool.
I'm glad to hear I'm getting some. I was going to ask how I get some, so you just volunteered that. That's all right.
Well, yeah, Paul, and if you get one of these mugs here and you forget the convective acceleration term of the shallow water equations, you got it right here in front of you while you're drinking your coffee.
Yeah, all I use anymore now.
I knew that was
is the weird.
I knew that was something you were really worried about.
Yeah.
Who needs caffeine when you can just look at the shallow water equation set, Chris?
Oh man, that's the opposite of caffeine. That'll put you to sleep.
Good. All right. Well, let's transition to the special topic for today, and that's going to be on dam breach analysis with an HEC-RAS. We wanted to bring this up because Paul is in dam safety. That's kind of his area of expertise, along with some of his experience with hydraulic modeling. So we thought it'd be a relevant topic to discuss. We get questions all the time about dam breach analysis. It's part of our training, but we thought we could kind of keep this informal and fun and just talk through some different things for people to consider when they're building out dam breach models using HEC-RAS. So, Chris, I'm going to start off with just a question for you, and that is, if folks are needing to do dam breach analysis and they're weighing the different pros and cons of the various software out there to do dam breach analysis, why would HEC-RAS be a good choice?
Oh, over other software?
Correct.
That can also do dam breach modeling? Well, that's a great question. Well, first of all, HEC-RAS is easy to use. It comes with a very nice set of manuals. And there's even a companion document called TD39 that is all about dam break modeling with HEC-RAS. So you've got a lot of resources out there. It's been used a lot for dam break modeling. I can remember I've been doing dam break modeling with HEC-RAS for over 20 years now. And so it's tried and true. The 2D especially is very robust and stable. And I'm not speaking comparatively to other software because frankly, I haven't used other software to do dam break modeling. I think I one time looked at a National Weather Service's dam break model output before. Never had the pleasure or maybe displeasure of having to run a NWS dam break model. All my experiences in RAS, but it is very robust. And hey, if you know the tips and tricks for stabilizing your model, you'll be in good shape. And one of the things about HEC-RAS and really any computational model, I would venture to guess, but certainly with HEC-RAS, is it does not like sudden changes, big dynamic changes. Whenever you have big dynamic changes, both in space and time, that's when the model starts to complain with you and fights with you, and possibly goes unstable. And what has more sudden changes as an application than a dam break, right? So dam break models are among the hardest to stabilize in HEC-RAS, especially if you're doing 1D unsteady dam break modeling in HEC-RAS. And so knowing the tips and tricks is a big part of it. And so that would be my first contribution to this discussion.
Yeah. Paul, anything come to mind in terms of, again, if people are kind of weighing the pros and cons, things that you like about using RAS for dam breach analysis?
Before I get there, Chris, I have done the old dam break model, and
I knew you. I assumed you've done it all, right?
And
you had to have done dam break.
it's pretty simple, but it is kind of a pain. But would not recommend it. What I think is so good about the RAS interface now with RAS Mapper, before that that upgrade, I mean, you have to do all your inundation mapping almost by hand, right? You get a water surface elevation, and then you're tracing on a contour map or quad map or whatever you have. Now the interface with the mapping just makes it so much simpler, and it's really robust and intuitive. In the dam safety world, HEC-RAS is, I think actually the FERC guidelines still say the old dam break model, but everybody knows that HEC-RAS is very much a widely accepted model. If you start going with different applications, you might have a little bit of pushback because the agencies sometimes want to dig into it and review it and make sure they can use that software. So anything that's free and widely accepted, that's where I would go right away. There would have to be a pretty extreme reason not to. I've seen cases where if like you're doing tailings basins and you have to actually model the outflow from a tailing situation, which is very different than say water flow. I mean, Flow 3D has done it. Flow 2D has done that as well. So I'd say there are definitely applications out there that warrant using something else. But if we're talking in the dam safety world, that's where I would go right away.
Yeah. And now with the latest versions of RAS, you can do tailings dams.
Yeah. I haven't
debris flow, non-Newtonian. Yeah.
Right.
Sorry, Ben, you were saying something.
Yeah. The only other thing I would add in terms of, I think a real pro is around the idea of being able to quickly generate bathymetric data in RAS Mapper with the new terrain modification tools that we have available to us. There are certain applications when you're doing hydraulic modeling in which you need, really detailed bathymetry data. Think about river restoration, fish habitat analysis, fish passage around, nature-like fishways, things like that, where detailed bathymetric data is going to be really, really important. Damreach analysis doesn't really fall into that, right? Like we can kind of get away with approximate bathymetric representations. And, so we have that side of the coin, along with the fact that with Damreach analysis, often the terrain data that we have over the whole study area that we need to model with inundation boundaries, oftentimes we don't have bathymetry through the majority of that area, right? And so it's so easy to, with the new terrain modification tools, to add approximate channel dimensions into our terrain model and then use that updated terrain data set to model that breach wave and the routing of the breach wave. I think it just is a really powerful way to maximize the utility of the program without spending a gob of money creating this really detailed bathymetric data set.
Yeah, and some of those models can go hundreds of miles downstream, right? So if we're talking about getting out and mobilizing and collecting it, there's not much return for that value, right, of going out and doing it, because again, usually everything's contained within the banks during normal flows, and then during a big breach it jumps over. So it really doesn't make sense unless you're doing certain detailed studies where it's like, hey, if we had some survey data in this location or that, it might change the answer a little bit. But to get started, yeah, I mean, cutting in a channel with old floodplain data, old models, and then relying on available LiDAR for your terrain is usually very well accepted.
Yeah, good. Well, I don't want to get too far down into our next topic, which is a little bit different than why use HEC-RAS, and that is if you've made the decision to use HEC-RAS for Damreach analysis, what are some things that each of us can think about that we would like to share with the general public, things to consider, lessons learned, tips and tricks that we've picked up over the years of doing Damreach analysis. Chris and Paul have been doing it a lot longer than me, but I have done a decent amount. So I'd like to think I can contribute to this conversation at least a little bit. So that's kind of the first starting point here. So Chris, I'll start with you. What's one thing that somebody, if they're doing Damreach analysis with HEC-RAS, should definitely consider?
So I kind of touched on this a little bit ago, but the fact that RAS does not like sudden changes in anything. And so my tip would be, whether you're doing 1D unsteady dam break or you're doing 2D dam break modeling, there's a high potential that you're going to get errors and possibly instabilities and maybe even a model crash at some point. It can be really, really difficult to troubleshoot that, to fix it, figure out, number one, why is it crashing? And then number two, how do I fix it? And there's almost an infinite number of reasons or causes for your model to crash, right? So it's impossible to say, all right, here are the reasons why your model will crash, and this is how you fix it. There's no way you can create a list like that. So what you have to know is the fact that RAS doesn't like dynamic changes, sudden changes and things. That's likely what's causing your model to crash. So find where that's happening, narrow in on that, and that's going to be your best bet for figuring out why your model's crashing.
Yeah.
And I picked that one specifically for this topic because Damreach models, by far, in my experience, are the ones that cause your model to crash more than any others.
Yeah, I'll just build off of that, Chris. I think it'd be reasonable to say, as part of that, anytime you do a Damreach analysis, it probably is worth making sure you do a regular hydraulic analysis before you actually start doing Damreach, right?
Yeah, absolutely.
Cool. Paul, I'll go to you. What's one thing that, top of mind that you can think of that somebody should strongly consider when they're doing Damreach analysis with RAS?
Yeah, couple things that come up, like I said before, is just to start really simple. Some people like to go into it and build up so much complexity in their model, and they're surprised where everything's blowing up. Like if your model has 5 dams in it and they build 5 dams right away, and they're like, well, it's unstable everywhere. It's like, well, where's your issue, right? So what I always kind of recommend is almost have a really truncated model to start with, just your dam a little bit downstream, get some water going through it, understand, get your dam stable, and then build complexity downstream once you're feeling good about it. If you're using 1D RAS, the other thing I always say is, well, just run your non-failure situation in unsteady or steady state. Just get water pushing through it, because you're going to have to really rely on your boundary conditions, right? So do you have downstream dams? Have you established where the normal water level should be? Is the model computing that or predicting that properly? So really going in there, starting simple, thinking about boundary conditions, and then just expand complexity before you really get too far down the line, because you can get pretty frustrated pretty quickly if you're not doing a stepwise approach. The other thing that is pretty rare that I just don't see very often, but it's an important step if you can, is try to calibrate your failure model if you can. And what I mean by that is, if you're working with your owner, or if they own a series of dams in the river, is getting whatever actual data they have at their site. So if they have peak flow records, headwater, tailwater, discharge. So when you're actually routing this flow, you're getting a result that somewhat matches what's been observed. If there was a historic flood in the area, see if you can capture some of that information, because ultimately what's going to lead to is potentially setting the hazard classification of your dam. And if you're doing risk, it could lead to, your life loss calculation or where it falls on those curves. So if you can at least establish that your model has some credibility with something that's been observed before you start projecting up to these bigger, PMF events that no one can even comprehend anyway, it just helps build some confidence in what you're doing. I guess a quick example of this is, we were doing a model recently, and we had no information beforehand, but the client actually came back to us and said there was aerial footage captured by drone from a big flood 2 years prior. And we actually went through that frame by frame, and we pulled the flow records from USGS gauges and outflow from the dam. And we actually just did a stepwise screen capture of the model with screen capture of the drone footage, and was like, hey, our model here is predicting pretty well what happened during that flood event. And then it helped build the case for the IDF study, which really helped set that. So if you can calibrate it, do it, because a lot of people sometimes skip that step. They just, hey, let's do a dam break of a PMF. And it's like, well, no one can wrap their head around a PMF anyway. So is there something in between we can calibrate to?
Yeah, that's great. I will add my first special consideration, and that is, whenever you're doing a Damreach analysis, you're going to have to make a number of key assumptions, right? Those assumptions can be around things like bathymetric data, can be around scour, can be around incorporation of bridges. And, you can have 2 different engineers that make 2 different sets of assumptions in the exact same scenario, right? So there's an acceptance that there's going to be a variety of opinions, but ultimately many of these Damreach analyses have to be reviewed by FERC. And so my kind of, recommendation is, try to involve FERC and the folks that are going to be charged with reviewing your analysis early in the process, and run some of these assumptions that you're going to make by them early in the process, such that if there's disagreement, again, you can have two different people that are both educated, have different opinions. If that's the case, you can kind of make some adjustments to your approach early, as opposed to going through this whole shebang, getting to the point where you submit, Damreach analysis inundation maps to FERC to review, and they have a problem with this kind of fundamental assumption that you've made, right? So involve FERC early in the process, as early as you can, with an understanding that obviously sometimes you're not going to be working with the same FERC person, so they have the right to change their mind, but it certainly helps to involve them early.
Yep.
Chris, what's another thing that's
I think one thing everybody who's embarking on a dam break model needs to know and really understand is the extreme uncertainty that you're dealing with in doing a dam break model. A conventional, regular hydraulic model, you're modeling a river, maybe there's some bridges in it, whatever. Your most uncertain terms or most uncertain inputs, I would say, are your end values and your inflow hydrograph. And depending on how good your hydrology is, maybe the end value is more uncertain, maybe the hydrology is. But when you get into dam break modeling, those breach parameters that you use to define the size, shape, and formation time of your breach are I've found anyway, an order of magnitude more sensitive, or the results are an order of magnitude more sensitive to the dam breach parameters than they are to the end value. So just understand what you're doing with the software, that it's a tool to help you make decisions, in the case of dam break modeling, maybe to help you have a better understanding of the risk, what kind of consequences you have downstream of a dam if it were to fail. To get you in the right hazard classification. But one thing you should never expect from a dam break model is that you're going to get the right answer. You're going to get an answer, and you want that answer to be useful to you and to what your objectives are. But there is a lot of uncertainty with that. So, and the other thing is, as you kind of touched on, Paul, you can't really calibrate a dam break model, certainly not to the level of flow you're going to have. So you have to rely on sensitivity analyses, right? And do a lot of that to really understand what you're dealing with. Sorry, Ben, what were you saying?
Yeah, I was going to say, if people are interested in understanding better what the range of those breach parameter outcomes are, and they're not able to do that with just a standard old school traditional deterministic way of assessing those parameters, there is probabilistic dam breach software out there that can help kind of quantify what that uncertainty is, how sensitive the overall breach result is to those dam breach parameters. And I know we talked about McBreach on this program before, but I think that kind of ties in exactly with what you were saying, Chris, right? Is there certain times in which an owner or a consultant's going to want to have a little bit more information in terms of what the range of potential up breach outcomes are? And that's when you probably need to start thinking about moving away from the old school deterministic approach and having some more probabilistic statistical analysis.
Yeah, agree, 100%.
Cool. Paul, back to you. Is there something else that kind of strikes you as being something people should consider when they're doing Damreach analysis with RAS?
Chris stole my sensitivity analysis.
Sorry, man.
But maybe
I figured there would be some of that.
Yeah. But to kind of build on that, and I'm sure you guys have touched on this before too, but the overall, understanding the overall input is wrong in HEC-RAS. Like whatever flow value you put in, that's not an exact science, right? If your hydrology is within 25 to 50%, you're feeling pretty good, right? So I think understanding that, to your point, Chris, whatever answer you're getting is not the answer. It's just there to help inform something going forward. So what I always try to communicate, even if it's not just a dam break model, is we run a range of scenarios, range of sensitivities, and it's really in an effort to bracket the results and say, for flows in this type of range, these are the types of impacts we might see. And with those different flows, the different maybe return interval or probability of happening, and ties that into risk too. So understanding also that whatever number you're given, or whatever output you get, it's not correct. It's just an estimate, right? And bracketing those results is very important. I will say, just there's been, I believe, 2 times now in my career where I've gotten a phone call about a dam either failing or it is about to fail, and having this conversation of, well, let's get out our inundation maps and let's start calling the emergency folks, right? So again, where you're going with that is to help inform the risk downstream to the public, and they're going to make a judgment call based on the maps and how they interpret it. So I think understanding that the answer is not real, it's a good estimate, and you have to use that to make a decision. And bracketing those results is really the way we should be interpreting it.
Yeah, those are some great kind of higher level recommendations that you guys both just gave there. I'm going to get a little bit more granular with my next one, and that is just understanding that the typical Manning's N values that you use in normal riverine modeling don't necessarily apply when you're doing dam breach analysis. As we all know, Manning's N value, the roughness coefficient, decreases as depths increase, right? And for a lot of these systems that we go out and get eyes on, a dam breach scenario is going to produce depths that river may have never seen before, right? And so having that understanding that you're not going to necessarily be able to go to the old reference manual for Manning's N and look at pictures of the substrate and choose a Manning's value from that. It's probably going to be quite a bit lower than that when you're doing dam breach analysis. And that can actually be helpful in terms of not overestimating inundation boundary, right? Because as Manning's decreases, you're going to end up having a lower water surface elevation. But it is, again, just something to consider. And a lot of people, I think, kind of just stick with those traditional roughness values in river modeling for dam breach analysis. And that's not always going to be appropriate. So.
One thing to add to that, Ben, that causes an issue if you're doing 1D, one of the ways to fix that is you just bump up your Manning's N values, and it really helps model stability. But to your point, now our inundation limits are a lot bigger, and it's like, well, is this realistic? So you have to there's a bit of a trade-off there between
stability,
getting your model stability versus how close are our numbers, and there's just a lot of different tweaks you can do to play around with that.
Yeah, absolutely. That's where, again, that kind of engineering judgment, past experience on how to do these things, is really, really important. Chris, I'll go back over to you. You got one more kind of tip for people?
One more tip for folks. Do some research. Search for dam failures. Learn about past dam failures. Read the reports. If you can see any of the videos, there are a few videos out there that show dam failures. Fortunately, these days you don't get them too often. And so a lot of the dam failures that we've learned about, there's no video evidence, but there certainly are videos of more recent dam failures. Some of them are quite, I don't want to use the word spectacular because that has kind of a positive vibe to it, but, quite extreme, I guess. And it's really good to see those to understand what you're trying to model. I mean, because most of us have never seen one in person, a dam failure in person. I don't want to speak for you, Paul. Of the three of us, you're probably the most likely one to have. But and so we're trying to model a process that we've never really observed before. Most riverine models, regular river models that we put together, we go out to the river, we observe the river, we look at it, we look at how flow goes around a bridge pier, and you can visualize that. And that gives you a real advantage when you're evaluating and interpreting your results. But with the dam break model, you don't have that benefit, that luxury. So learn as much as you can, learn the history, the big ones, the Johnstown flood, Coloco, Tom Sauk are more recent ones. Understand how that process works, and that's going to give you a better, what's that?
The Teton dam failures.
Oh yeah, Teton. Yep. And understand what happened with those, and that's going to give you a better, not just a better understanding of the physical process that happens, but it's going to give you more understanding about how to set up your breach, how to define it, and what realistically makes sense to you when doing that?
Yeah, good. It's a great tip. Paul, I'll go to you for your last consideration for folks doing this.
Yeah, I'll just maybe build off of what Chris was saying. If you get, into the CA or risk process, one of the things that you really need to do is look up old case histories, and Reclamation has got a really good database. So if you're ever, using a Damreach model to inform risk, it's very important to kind of compare that to case histories and kind of see how your estimate compares to historical ones in terms of potential life loss and those things. So there's a lot of good information out there that we should always try to ground truth, whatever we're using this for, just to previous events.
Yeah, good. I will close this out by giving one more, and that is, understanding how the size of your model might influence your decisions in terms of how you set up your model, including cell size and individual 2D areas. And what I mean by that is, as Chris noted, one of the real challenges with Damreach analysis is that sudden release of flow and the subsequent high velocities that you get right at the downstream end, or right at the tail of that dam release. So because of that, oftentimes that portion of our model, if we're doing 2D breach analysis, kind of governs what we decide for a time step throughout our modeling domain. And in many situations, that's fine. If we have a relatively small modeling domain, we can kind of get away with using a small computational time step that's going to keep our whole model stable based off of the velocities that are occurring right at the downstream end of that dam. However, there are certain conditions where, especially for larger dam breach analysis, you're going to have a very, very long model potentially. And so just being aware of that and potentially being able to pivot and say, break your model up into a couple different 2D segments, or maybe some 2D segments and some 1D segments to maximize the efficiency of your model. Because as everybody who uses HEC-RAS knows, you can actually choose a separate time step for different 2D areas that are connected within your modeling domain. Same with different 2D areas that are connected with 1D portions of your model. So having the understanding of evaluating the overall model extent that you need to build, deciding how to combine these different components, whether it be 1D, 2D, 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 to make your model most efficient as possible, is going to be extremely helpful, and will give you just more flexibility in terms of how to approach that problem.
Ben, can I add more dumb trick to the group here? See if you guys have ever used it before. But one thing you mentioned.
Are you going to talk about truncation?
No.
Okay.
So if in the 1D space, where if you have a really long downstream reach and the travel times just take forever, 1D can't be stable without water. So it really can struggle, and you can get a ton of errors at the dam you actually breached like 6 hours ago or whatever it is. A trick to stabilize those upstream issues is just there's a rebuild the dam tool in the unsteady. So if you actually rebuild the dam after you fail it, you don't have all those water surface errors you have upstream in the impoundment. And that's like a really common location where you have a bunch of errors. I can see Chris's head is blowing up there, but I've definitely used it more than
you just blew my mind, Paul. That is a genius idea I've never thought of, but I know exactly what you're talking about. As the reservoir drains down, your nice, stable, deep reservoir now becomes shallow and starts draining out. And we all know that when your depths get shallow, your stability goes up, or instability goes up, stability goes down, whatever. It becomes more unstable. On top of that, you're now dealing with submergence issues, and this will bite you in 2D models, especially where now your tailwater has come up to your headwater and they're almost the same level right over the breach, right? And that can pose all sorts of stability issues. You get oscillations, flow going back and forth. And to your point, yeah, if the peak of the flood wave has already passed, well, one thing you could do is you could just stop your simulation at that point. But if you need it to travel further downstream, then maybe you can't. You have to keep running it, right? And so I love that idea, Paul. I think that's genius.
I had to.
You get a hat for that. You get a full momentum hat.
I'll settle for some full momentum golf balls if you can get that.
Oh, there you go. Yeah,
Ooh, yeah.
The way I've combated that, Paul, in the past is to add a flow hydrograph location just upstream of the reservoir, and basically start adding flow right around the time where that dam breach passes. And it kind of accomplishes the same thing, but I like your method a little bit better. Because in all reality, that might actually occur, right? You might actually have an owner out there trying to rapidly repair a breach just in case there's another flood event that happens. So I think that's a very, very cool idea.
Yeah,
If anybody,
and maybe the coolest part of that idea is like I never found any use for that rebuild the dam tool. I mean, I thought it was just more of a gimmick in there. Yeah, Ben's pulling it up. And and that's how I would present it in the classes. It's like, hey, this thing's here. If you want to, for whatever reason, rebuild the dam, you can do that. So now I have a reason to do that. So thanks for sharing that, Paul.
Yeah. So for those that are curious about what Paul's describing here, this is your unsteady flow analysis plan. This is what you're going to run if you're running unsteady flow, 1D analysis or any sort of 2D analysis. You're going to need to use this. And you can access your breach parameters from this menu by going to options and either looking at your SA, 2D area connection breach, levee breach, or dam breach, depending on what type of breach analysis you're looking at. In all of these, this dialog will pop up where you can enter in your breach parameters here on the left. You'll want to make sure you have this breach, this structure option turned on. And the breach repair tool is the last tab in this on the far right side. So this gives you, again, some options in terms of number of hours after the full breach to start the repair, the total repair time, and the final filled in elevation. And so if you're having some issues with instabilities because of how your water surface elevation behind your dam is dropping after the breach and it's going unstable, this sounds like a potentially a good tool to help alleviate that. And again, most of the time when we're doing damage analysis, our focus is what's happening at the leading edge of that breach wave. Whatever's happening behind that is not of primary concern. So this would be a good approach. Chris, am I correct in thinking that another approach would be transitioning to finite volume in terms of the equation type?
Well, for 1D model,
and that's what we're talking about here, right? We're talking about 1D cross sections going dry and crashing, and if you switch to finite volume, that's not going to be an issue.
Yeah, I think in theory that would help. Yeah, I'm not 100% on board with finite volume yet, but in theory, yes, that would help. That, I mean, ideally, what finite volume does is it allows you to go dry or have really shallow depths in 1D models and not have a problem. But I'm not so sure finite volume is 100% ready for prime time. It takes a little understanding of what's going on. A little bit buggy in my experience, but yeah, I think ultimately that could be another option there.
Yeah, for those that are interested in what I'm talking about. So in the computation options and tolerances menu, which you can access from your plan window under options and clicking on that icon right there, under general, you have this 1D numerical solution type. By default, RAS uses the finite difference, which is the classic method. This is what, again, you're going to have issues with if your cross sections get dry or get really low, have really low depths. This finite volume is supposed to be a way to address that. So if you're doing, for instance, hydraulic modeling in the desert where you're dealing with completely dry conditions at the start of your simulation, and you need to be able to route a flash flood moving through that, and you have a 1D model, finite volume, I think, is kind of a method that's supposed to work for that. And Chris, maybe he's had some mixed experience. I've had success with it in the past when I've had these situations arise. So a couple different options there in terms of handling potential instabilities from a reservoir getting dry during a breach event.
Yeah, note that it's still beta, so use it at your own risk. But those beta features tend to be a little bit more buggy and maybe not as reliable, so just be careful with it.
Cool. Well, let's go ahead and close out today's episode with a quick discussion on a favorite dam breach project. And you don't have to necessarily name the name of the project or the client, but maybe it's just something about the dam breach analysis that you really enjoyed or that you found challenging and you were able to kind of overcome that challenge. So Chris or Paul, does a particular project or a component of the project kind of come to mind?
I'll let you go first this time.
Yeah, I wouldn't say it's just one project, but maybe a series of them. So on the Wisconsin River, there are just so many hydros that, if you're doing one dam break, you're probably routing it through 6 to 12 other projects. So what I enjoy about those is every time you're working on them, you're working with the same folks on the same projects, and you're very familiar with the system. So I think that has always been some of my favorite ones, and we've done those all in 1D. We've done them in 2D, combined 1D, 2D. So it's I always just really enjoy working for those clients on that system, just because I've spent so much time in my career working on them. But I'd say where I really enjoy it now is as we're transitioning into risk in terms of the new Part 12 process on CAs and life loss. It's just basically taking everything that I've learned and applied to date and just applying it to this newer process and risk. And I've really enjoyed collaborating with owners and other consultant teams to do so. So that's just been a kind of a change in the process in the last few years, but that's been really great.
I want to ask you something really quick, Paul, because knowing you already before doing the podcast here, but also learning a little bit more. You've had, I would say, the unique experience of being involved in emergency action situations with dam failures. Like you'd mentioned earlier, you would get the call, when a dam break is imminent or occurring, and without naming names and honoring NDAs and all that stuff. Can you tell us, those of us who maybe never will have an opportunity like that, what is it like in the middle of an event like that? After you get the phone call and you mobilize out, what are some of the things you've experienced?
Yeah, it's a great question. I'd say it's sobering, right? Because everything that you're doing here, it's just on paper, right? And now we're talking about folks that or you talk to that are trying to actively either flood fight or get folks out. And then, if it does happen, you see a lot of folks impacted. So it's just a very, I'd say, sobering experience. It's draining just, going through it. But, you ultimately start, thinking about the folks that are really impacted. So it's just a very almost non-engineering feel in the middle of a very technical thing that's happening. So it definitely sticks with you. And I'd say when you're doing these types of analysis, or you're talking about life loss and risk, I think it helps ground you a little bit too, because it's like, oh, well, I've got some real life examples of this happening. So hopefully never have to do it again, right? You don't ever want to get that phone call, but it's almost like you're just in reactive mode, and don't panic, and you talk folks through. You get the EAP going, you try to get everybody out and get off the dam, because there's very little. If your gates are open and the pond is still coming up, there's very little you can do besides get out, right? So hopefully never have to go through it again. But if you're ever in that situation, hopefully can remain calm and work through it. But yeah, definitely very difficult.
Yeah, that's too good a question for me not to have a follow up on. Paul, is there thinking back on that, is there one thing, having gone through that experience, that you now do differently when it comes to producing dam breach analysis products, in practice?
Yeah. I think when you're preparing maps, don't have elevations on them, because they don't mean anything to anybody. What we should be having on our maps is maybe depths and flood arrival times, right? Because if you're making a decision on who you're going to evacuate or who's going to be underwater, the question more should be, well, how much are they going to be underwater and how fast is it going to go, right? Because an elevation in real time does not mean anything to anyone. They don't care. They don't know what the elevation of the road is, or their house for that matter. So if we are using maps for emergency management, we should really be reporting depths instead of velocity. We can report the water surface elevations, but the maps should be all depths to help inform those decisions.
That's good. Yeah, I think we tend, as speaking as somebody who hasn't gone through that, kind of tend to focus on water surface elevations because oftentimes it's what kind of our objectives are leading us towards, whether it's, doing IDF determination and looking at what incremental rise is, right? That's all about water, how water surface elevation changes. And so I think it's easy to kind of fall into that trap and forget what is going to be the most useful information in a stressful situation where you need information quickly. And like you said, water surface elevation it's going to be thrown out. It's not going to be something that people can use in a real way. So thanks for sharing that. That's really cool. Yeah. And again, hopefully something that most folks who do Damreach analysis don't ever have to go through, but I think this has been a productive conversation. Chris, I do want to give you a chance to just briefly mention your favorite Damreach project or piece of the project that you enjoyed the most.
Yeah, sorry to take us a little off track there, but you can probably guess my favorite model is still the Missoula floods dam break model, which is not your conventional dam break. It was a model of an ice dam failure that happened several times in the last ice age. So we're talking anywhere from, I think, 12 to, 15, 18,000 years ago, something like that, in that range. And the ice dam was around the Missoula, Montana area, and it was roughly 1,000 feet high, blocked the Clark Fork River. And when that failed, it sent a massive flood wave equal to 10 times all the rivers in the world combined down through eastern Washington, through the Columbia River Gorge, out near where I live, and ultimately out to the Pacific Ocean. And everything in the area I live, well, and you live too, Ben, has been shaped by the Missoula floods. And it's a lot of fun checking things out. I can zoom into areas of interest. I can put some refinement regions on it and rerun the model and really see, what it looked like during these massive floods. Yeah. And that's been a lot of fun, and it's been fun sharing it with people too.
Yeah, for those that are interested, episode 8 of this podcast, Chris shared a lot about his 2D analysis of the Missoula flood. So if you're interested in more information on that particular event and project that Chris worked on, check out episode 8 of this channel. That was way back in 2020, Chris. But yeah, that was.
Whoa, we've been doing this that long? That's crazy.
No. Well, I'll finish it out then by describing my favorite Damreach project, and it was one that wasn't for a client that we got paid for, but it was as part of a senior design project that I was a technical advisor on, adjunct faculty at Gonzaga University last year. Had a chance to go back to my alma mater and be a senior design advisor for that team, and they were in charge of doing a Damreach analysis for a dam in Spokane, on the Spokane River, and they did a great job. It was a challenging model. It was a very interesting dam setup. I believe we actually had Esme on the podcast a couple episodes ago, and she shared a little bit about that project. But that was the coolest for me because, one, it was really hard to manage a group of students, very different than managing a group of consultants, but also just to kind of see the evolution of understanding of kind of how dam safety plays into civil engineering as a whole, and how hydraulic modeling can help answer some of those tools. And I know at least 2 of those individuals are currently in the water resources dam safety world. I would like to think for a small part because of that project. So that was the coolest for me, just kind of from a holistic standpoint. And obviously, anytime I can mention Gonzaga on the podcast, I'm going to do that.
So. Well, the important question, Ben, did you learn, is the campus at risk from that dam failing?
I will leave that to the publicly available information that is out there, Chris.
So. And this is all hypothetical too, by the way. So,
but yeah. Anyway, all right. Well, Paul, this has been really great. Appreciate having you on. I think everybody will find this conversation very insightful, particularly those that do Damreach analysis. Do you or Chris have anything to add before we part ways for today?
Just say thanks for having me, guys. This was great.
Yeah,
Chris?
it was great having you on, Paul. I always thought that you'd be a lot of fun to have on the podcast, and you definitely didn't disappoint. So thanks for joining us.
Cool. Well, maybe next one we'll have to do live at a conference again, Chris, like we did at ASFPM, and we can have Paul recruiting all of his industry contacts to come on and talk about RAS a little bit. That would be fun.
There you go.
Cool.
Earn that swag.
Well, thanks again, everybody, for joining us here today. Don't forget to check out rastraining.com if you're interested in getting some hydraulic modeling training on RAS 2D. Our next class will be offered this fall, and we're really excited to start that journey with anybody who wants to jump on. So thanks again for attending today's podcast. This has been Full Momentum in HEC-RAS podcast. Until next time.